you want to find the volume generated when the area between the curve, I show you where I mean, right? Area between the curve. This is the area between this curve, right? Area between the curve and the y-axis. Okay, this area here is rotated about the y-axis. So when you rotate about the y-axis, the formula for rotating about the y-axis is pi x squared dy. Integrate pi x squared dy, because it is between the curve and the y-axis. So everything must change to y. No, the problem is this one, pi x squared dy. You have to find out what is the x square first. Okay, so how to find out the x square? Now we come up with this equation, y square equals to 4x. So you copy the equation here, y square equals to 4x. And you have to make x the subject of the formula. So if you want to make x the subject of the formula, you have to move the 4 over to the other side. So now the x becomes the subject of the formula. But I cannot use x because the question here says integrate x squared dy. So I have to actually find out what is x squared first in terms of y. Okay, so in order to find x squared in terms of y, I have to square both sides of the equation. On this side, when I square, it becomes x squared. On the other side, when I square the y square, it becomes y to the power of 4. And when I square the 4, it becomes 16. Right? Okay. So all this, I substitute into the x square here. The x square here. Right? So actually what we have now, what do we have? Okay. So we have the volume of revolution is integrate from y equals to 0 to y equals to 3. Y equals to 0 to y equals to 3, pi x squared dy. Finally, the x squared you have to change to y. X squared change to y. Where this thing come from? From what we have found earlier. X squared is y to the power of 4 divided by 16. Right? So the pi and the 16, they are constant. You don't have to integrate them. So I take this pi, I put outside. The 16 also I put outside. So what I need to integrate is y to the power of 4. So when you integrate y to the power of 4, it becomes y to the power of 5 divided by 5. Okay. So substitute the numbers inside. So when you substitute 3 inside, it becomes like this. 3 to the power of 5. When you substitute y equals to 0, the whole thing becomes 0. So finally, you have 30 and 3 over 80 pi unit cube. Any question? No question. Other girls, any question? So if you have no questions, then we move on to the next type. Okay, so again, we look at the volume of revolution. One problem is between the curve and the x-axis, is rotated about the x-axis. Another problem is between the curve and the y-axis, and this part is rotated about the y-axis. Okay. Another thing you have to be careful is the square of the function. Now sometimes the square of the function is readily available. You don't have to square them. Sometimes you have to square them. Okay. Now in our previous example, I've shown you, you have to square the thing. Okay. You see, y square, then I have to square the function, square the y. Then you see that we have x square here. Now this is only x, so I have to find x square, and I substitute this x square inside here. Okay, so because the square of the function is not readily available, so I have to square them. However, I'm going to show you one question which is slightly different, right? So we look at this example here, question number 2 on the left hand side, on the right hand side, sorry. So we look at this question here. This question, there is a curve called y equals to 7 minus x squared. Now this curve is rotated 360 degrees about the y-axis. So by right, what we want to do is we want to integrate by x squared dy. Everything we change to y, right? We start off with x squared, never mind, but finally the x squared we have to change to y, right? Okay, so we know that this is the volume between the curve and the y-axis. So the formula is like this, right? By x squared dy. Right? Okay, so the function I copy down here, y equals to 7 minus x squared, I copy down here. Now can I use this function y equals to 7 minus x squared and substitute inside here? Right? Cannot, right? Cannot substitute directly because you need to substitute x squared. So from this one, from the first equation, I have to make x the subject of the formula. So when I move the x square over to the left hand side, the y I move to the right hand side, so becomes x square equals to 7 minus y. Now if you look at this equation here, it is already in x square, and here also they ask for x square. So what am I supposed to substitute inside the x square then? I need to substitute what inside the x square here? I have to substitute the x square with 7 minus y. Why 7 minus y? Do I need to square it again or not? Do I need to square it again? The x square I replace with 7 minus y. Do I need to put 7 minus y square?
Yes.
No need. Why? Why no need? Because x square is already 7 minus y. This 7 minus y is already x square. So you don't have to square here. You don't have to square again. So
Okay,
the whole
teacher.
thing is already x square. So you have to look at the question. If it is already in x square, you don't have to square them anymore. If it is just in x, then you have to square it because they want x square. It's the same thing with the y. If they want y square, if it is already in y square, you don't have to square them again. If it is in y, then you have to square them because you have to integrate y square, right? Okay, so you don't have to square anymore because this is x square already. Okay, so then you integrate directly. 7 becomes 7y because you integrate with respect to y, right? So it becomes 7y. Integrate y becomes y square over 2. Y square over 2. And the pi, you just leave it outside the bracket there. Finally, you substitute 7 inside the definite integral. Substitute 7 becomes 7 times 7. Substitute 7 becomes 7 squared over 2. Then minus substitute 0. So substitute 0, everything becomes 0. So the final answer is 49 over 2 pi unit cube.